Suppose you wanted to determine the actual physical size of the diameter of a planet. Imagine you look in your telescope, you see Neptune. All that you're going to see in your telescope is just going to be an angle. That is the angle from one side of Neptune to the other. The diameter of Neptune, might be a tenth of a degree or 25 arc minutes or 2 arc seconds or something like that. That's all you're going to measure in a telescope. We don't see anything else. But if you add to that measurement a knowledge of how far Neptune is from us, you can actually come up with a physical size of Neptune. And I want to talk a little bit about how we're going to do that. So we're going to be dealing with 3 different quantities. One quantity is going to be theta, and that's going to be the angle subtended if you look at Neptune. You're also going to be talking about the distance that Neptune is from us. That's going to be distance. And the other thing, let's choose the letter S to represent the size of the object. Maybe it's the diameter of Neptune, maybe it's the size of a crater if you're looking at something on the moon. You have to know the angle that it subtends, you have to know the distance, and you'll be able to determine what the size is. So how do we do that? Well, let's imagine that we're going to choose a particular thing to observe, and I'm going to observe it by standing at this point right here. See where that dot is? That's me. I'm the observer. I'm going to be standing right there. I've got a telescope. I'm going to be looking through the telescope, and I'm going to look at this little thing right here, this little chunk of the size of the circumference of that circle. So imagine that the circle has a radius. I'm going to call that radius d, because that stands for the distance from me to the object. Okay, and this will be the angle that object will subtend. So the object will have a size s, and this angle right here, that's going to be theta. Okay, that's theta. So we can come up with a pretty nice relationship between these things by a little bit of a pretty straightforward reasoning. Imagine the following. I look at this situation, and I can see that there must be a very simple relationship between the fraction that this angle is and the fraction that this distance is, s. And that relationship will be the following. Whatever theta is, theta divided by 360 degrees, that ratio, maybe theta is 1 degree, 1 over 360. So theta divided by the entire angle completely going around the observer, all around, is got to be exactly the same as the ratio of this little length, s, to the entire circumference, going entirely around the circle. That'll be s divided by the circumference. Okay, and we know how to write a circumference. Go back to some introductory geometry class that you all had years ago, and that the circumference is going to be 2 pi times the radius of the circle. And we know the radius of the circle here, it's going to be d. So 2 pi d is going to be the circumference. That means our problem is solved. All we have to do is solve for theta. We'll end up with a relationship that's going to look like this. Theta is going to be equal to s divided by d. Now I'm going to take this denominator, 360, I'm going to multiply each side by 360. That's going to be put over here. 360 degrees divided by 2 pi. And that's all it is. I've just taken this equation, changed one little thing by moving the 360 over to the right hand side of the equation, and we're left with this. And guess what? If you divide 360 by 2 pi, you'll get 57.3. So the relationship is going to be the following: 57.3, that's going to be in degrees. That means the answer is going to be in degrees, times the size of the object divided by its distance from us. And this should make sense, because we would expect that the angular size of an object will be bigger if the object itself is bigger. That means the angle subtended will be directly proportional to the size of the object. And we'd also expect that the angle subtended will be inversely proportional to the object's distance from us. If it's further from us, if distance is greater, the angle subtended will be smaller.